Hi there, my name's Andy Perrin, Product Marketing here at OnApp. I'm going to be your guide through this video tutorial about OnApp Storage. OnApp Storage is a really exciting new product for us. It's a scalable, distributed block storage system. It's fully integrated into our cloud management platform, and we developed it so that service providers would no longer need to go and buy an expensive standalone SAN when they build out their cloud. We think it's going to really shake up the market, and we'd love you to come and try it. So go grab a coffee, make yourself comfortable, and hopefully this will be a useful 15 minutes of your time. Let's start this tutorial at the dashboard homepage of our 3.0 control panel. The way it works, OnApp Storage combines the drives within each hypervisor server and aggregates these into virtual data stores, which are created and managed through the user interface. And we can also configure essential features like overcommit, replication, striping, and failover all through the same UI. So the first thing we need to do, assuming this is a fresh install of OnApp, is to enable storage. So from the dashboard we go to settings first, and then from here we can see multiple options. We'll choose configuration, and there are a number of settings here, but we're going to focus on a couple of new ones that we see at the bottom of the page. Firstly, we need to enable cloud boot. This is the feature that allows us to network boot hypervisors as they come online. It's a really useful new feature to speed up provisioning times. There are two settings under cloud boot which need to be configured. The first, we need to specify the static IP address of the control panel server that we want to boot from, and then we need to enter the address of the cloud boot target. And in a typical installation, these are the same. Next, we need to enable OnApp Storage, and if we want, we can also tell the system to use the local read path, which basically means it becomes virtual machine location aware, and that can significantly improve performance by optimizing the location of the VM relative to the storage. So now that storage and cloud boot are enabled, we need to go to hypervisor settings to add some IP addresses for the cloud boot servers to acquire. So these fields all need to be populated, and first we'll enter the internal subnet of the management LAN. We'll go from 100 to 110 to give us enough addresses. We'll give it a net mask, and then we'll fill in the gateway address, which is the IP address for the control panel server. And obviously this is specific to each individual environment. Once we've submitted those settings, we'll see the IP addresses for the cloud boot servers appear on the next screen. And now we've added those IP addresses, the hypervisor servers have been powered on in the background, and they're now detected by the control panel server. We'll set them up as KVM nodes, and the first task is to select the MAC address. Next, we'll give the machine a name. We will be able to assign an IP address, and we can choose from the IP address list that we added earlier. We can go on to specify the hypervisor type. In this case it's KVM, and we'll leave the rest of the hypervisor settings as default. You'll see that we have the option to format the drives if this is a fresh install, and we can also select the drives we want to use as part of OnApp Storage, and as we're cloud booting them, we've got access to all of those drives. Lastly, we can specify which NICs identified by their MAC address are going to be assigned to storage, and in this case we've only got one NIC available on this hypervisor, but you can add more than one NIC if you want to bond them. We'll assign the NIC to the SAN subnet, and then we'll click on save, and at that point the hypervisor will get rebooted and come back up as a KVM node. Now if we go to the hypervisor view, we can see that the machine is not yet online, as would be indicated by a green button here next to the hypervisor name, but it will be very shortly. So now we will come back to the hypervisor status screen after we've added the other two hypervisors into the cluster using exactly the same process, and here they are. You can see that they're all showing as green and are now available. And if we want to see the storage available on these servers, we can go now to the integrated storage view, and we'll see that there are a number of drives distributed across each of these hypervisor servers. And in order to make these usable, we're going to add these hypervisors into a hypervisor zone. We'll go first to Settings and then to Hypervisor Zones, and from there we'll choose to create a new one. We'll call it KVM Zone. And if we save that, we'll go on to the next screen and we'll see that there are 3 hypervisors which are currently unassigned, and we can go ahead and add those into the zone by clicking on the plus symbol on the right hand side, and we'll go ahead and add all 3 of them. And now those machines will become available for hosting virtual machines and provisioning storage. So the next stage is to configure our integrated storage drives. So we'll go back into integrated storage, and we need to select the correct API endpoint, and that means choosing our newly created KVM hypervisor zone that we want to manage. So we'll see that in the drop down option there, and we'll click on Save, and now we'll go to the data store view and we'll be able to see all of the drives available, any of which we can select when building our new data store. So let's do that now. First we'll give the data store a name, and then we'll be able to specify properties for that data store underneath the advanced options. And specifically, there are 3 key settings. Firstly, there's the amount of data replication. So for example, you may want 2 or 4 replicas of data across your drives, or just the one if no redundancy is required, and here we're going to select 2. And then next we look at the striping policy. So this is the number of spindles that the data will be spread across, and you need to remember that there has to be sufficient drives available to match the replication and striping policies that you set, and here we're going to go for 2 stripes. And then we come to the overcommit policy, and this is where you can specify the amount of over provisioning that you require in different amounts. We can select 20 or 50% or unlimited if there is to be no limit on the amount of overcommit that can be set. Next we will specify which drives we want to add to the data store, and you can see here that the drives are classified by performance level. So we're currently looking at low performance drives, but equally we could create a medium or a high performance data store. All drives must be of the same level within a data store, the same performance level, and here we're going to create this low performance data store by selecting the relevant drives, and then once it's saved we'll see that the new data store has appeared. And if we hover our mouse over the name of the data store, we should be able to see the members appear highlighted across the 3 hypervisors. And if we also click on it, we can see other information like the amount of usable space in the data store once the replication factor has been taken into account. We can also see there are no virtual disks currently allocated, but as we start to create virtual machines we'll see them appear in this list later on. So now we're going to create a second data store, and we'll make this a medium performance data store. We'll go on to the advanced options and set the replication and striping policies. We'll configure just 1 copy of data, but with 2 stripes, and as you can see there are just 2 drives left, so we'll select both of those. We'll define the data store as a normal or medium performance data store and click on Save. And now we can see both data stores. If we hover our mouse over the latest one, we'll see just the 1 member in it currently, but if we refresh the screen we should see both drives, both members now appearing. So it's useful to know that there are certain properties we can establish about an individual drive within a data store. So by clicking on the individual icon, we can go on to see different information such as the model number, the size, and different statistics. So for example, we can look at how many writes to the drive within a given time frame. And there are a number of different views that we can select, and we can adjust the time period that we want to report on. Another useful feature is that we can adjust the automatically assigned performance category if required. So by clicking on Edit Node, you can see the categorization that we currently have assigned, and that can be modified if you, as the administrator, believe that it should be set differently. The final step before we're ready to go is to create a data store zone and add our newly created data store into it. So we go to Settings and then Data Store Zone. We create a new one. We'll call it Integrated Storage, and into that zone we'll add our mid-performance data store by clicking on the plus sign on the right hand side. And then finally we'll go to Hypervisor Zone. We'll select the hypervisor zone that we've been working with, and then we'll click on the Actions button and Manage Data Store. The last step is then to add the data store into it. And that data store zone is now ready for us to provision virtual machines into it. To show that, let's go ahead and create a new VM using the wizard. First thing that we'll see is the template store, showing all of the available templates that have been added to this cloud. We'll select CentOS 6, and we'll be able to select the hypervisor zone where that VM is provisioned. We'll choose the KVM zone that we've been working with, and the system automatically selects a hypervisor. We'll leave the password blank and let the system automatically generate one, and then we'll see the resource screen. Let's leave the default values as they are. Now for storage, we can see the integrated storage data store zone and the default size of 5 gig, and it's the same for the swap disk. We've only added one data store zone at this point, so that is selected, and the size again defaults this time to 1 gig. We'll leave the network zone as it is, change the port speed to unlimited, click on Next, and that takes us to the final stage of the VM creation process. We'll leave the values as default, click on Create, and the VM process is now underway. As you can see, it's not built yet, but it will be shortly. The provisioning tasks are underway, with the first of those being to build the drives. Now this process does complete very quickly, and once the VM is created, we can then connect to that virtual machine via the console. So finally, we're going to have a look at a couple of important ways that drives and their content can be managed in OnApp storage. So if we click on the first data store that we created, we can see what virtual disks or vDisks are running. That means the storage that's associated to an individual VM. So here we can see 2 virtual disks that are both running in sync with no issues, and there are 2 replicas of data for every virtual disk. Now we've rebooted one of the hypervisors to simulate a fault and register an error on the data path. So now we can see that the disks are out of sync, but of course the customer's virtual machine will still be running using the first disk thanks to the redundancy policies that we set for this data store. So if we select the disk, we can see that it shows as degraded, and now it's possible to click on the repair disk option, which kicks off a repair task that's shown then running in the activity log. Now you can see at the bottom of the screen that the task has completed, and the disk now shows as consistent with both replicas in sync. Now in other circumstances, you might need to move the content from one drive to another, for example if you were replacing a drive due to a fault. Clicking onto the first data store, you can see that there are 7 drives in there. Now we configured the data policy for there to be 2 replicas and 2 stripes. Scrolling down, we can see the virtual disks, the storage allocated to the VMs we created earlier. And if we click on one of those disks, we'll see the content owners are distributed across 4 drives in the data store. Now by selecting or deselecting the drive we want to replace and then selecting a new drive, either in the same physical server or in another one, we are effectively taking the drive out of service. And we do that by clicking on Rebalance. And you can now see the task is running in the activity log, and after a few moments it will complete successfully and the original drive then can be replaced.
And that's all for this storage video. If you'd like to get in contact or find out more information, the details are on your screen now. Thanks very much for watching.